So let's get a couple of these little review prompts here and make sure you have a little practice here for review. So we left off with a couple of those simplifying the radicals. So let's go into the rationalizing binomial denominators. I think that's one we should go over. So here we're going to simplify by rationalizing. So rationalize denominator and simplify. All right, rationalize the denominator and simplify. All right, so here we got -6 over -7 minus the square root of 13. So we want to get rid of the square root of 13. We want to rationalize that. It's an irrational number right now. Since we have two terms down here, we multiply by -7 plus the square root of 13. Numerator and denominator. Okay. Now we distribute. -7 times -7. 49. Now, when we do this, we're going to have -7 plus the square root of 13. So -7 root 13. Here we get +7 root 13. So they cancel. You get -7 times the square root of 13. A negative times a negative is positive. So +7 times the square root of 13. So those are going to cancel. And then we're left with negative times positive. So negative times positive right here. Negative. And then square root of 13 times square root of 13 is 13. Up top, we can distribute the 6, right? -6. -6 times -7, 42. And then -6 times positive square root of 13 minus 6 square root 13, which is equal to 42 minus 6 times the square root of 13 over 49 minus 13, 36. And now notice this has a factor of 6. This is 6 times 7 minus, here's obviously a factor of 6. And then this is 6 times 6. So we have this common factor here that cancels out. 6 cancels out, 6 cancels out, and a 6 cancels out. So the end result and simplified is what we have left here. Well, that's gone. 7 minus 6, right? Square root of 13. All that is over what? 6. Okay, so that's the simplified answer. Okay, rationalized and simplified. Okay. Now if we go over and do this one now, same thing, rationalized and simplified. In this case, we're going to go with square root of 7 minus the square root of 3 over the square root of 7 minus the square root of 12. We want to get rid of both square roots. So now we do a very similar thing, except now we multiply by the square root of 7 plus the square root of 12. Square root of 7 plus the square root of 12. We have binomials here, so I want to make sure we're thinking that we're going to distribute everything. Now we multiply it out. Maybe we'll start with the denominator. We have the square root of 7 times the square root of 7. 7. We have the square root of 7 times the square root of 12, which is square root of 84, positive. Here we have a minus square root of 84, so those cancel. Positive square root of 84 minus the square root of 84. And then last we have a negative square root of 12 times a positive square root of 12, which obviously there should be minus 12. Up in the numerator, we have the square root of 7 times the square root of 7. 7. We have the square root of 12 times the square root of 12. The square root of 7 times the square root of 12. That's positive square root of 84. All right, or 7 times 12. So sometimes we might want to just leave it before we simplify as that, right? Square root of 7 times the square root of 12 is the square root of 7 times 12. Then we have minus root 3 times positive root 7. So that's minus the square root of 3 times 7. And then lastly, we have the square root of 3 times the square root of 12. So that's going to be minus the square root of 3 times 12. Now we're going to simplify. Well, keep in mind, 12 here is 4 times 3. So this has a perfect square factor of 4. The square root of 4 is 2. So now we're going to have 7 plus 2. And then what's left? 7 times 3 is 21. Minus, here we have square root of 21. And over here, what do we have? We have, again, here 4 times 3. If you look at all this, we have the square root of 4 is 2. 3 times 3 is 9. The square root of 9, right? And in this case, if we look at all this, that's 36. And the square root of that is 6. So we have minus 6 all over negative 5. Lastly, we have 7 minus 6 is 1. We have 2 square roots of 21 minus 1 square root of 21, which just leave us with 1 square root of 21. And all that is over negative 5. So that's the end result simplified kind of nice and neatly. Okay, so again, we have this conjugate we're multiplying by, and then it's a matter of simplifying your radicals to get to the end result. Another one similar to that, same thing, rationalizing and simplifying. 5 minus the square root of 5 over 7 minus the square root of 5. So here we only have this single radical here, okay? So we're going to multiply by 7 plus the square root of 5. Here, 7 plus the square root of 5. Seven times 7, 7 root 5 minus 7 root 5 cancels. Minus, negative times positive, root 5 times the square root of 5, 5. Up top, make sure we do 5 times 7. 5 times the square root of 5. 7 times negative root 5 minus 7 square root of 5. And then lastly, negative square root of 5 times positive square root of 5 would be minus 5. Now, what do we have? Well, we have 35 minus 5, 30. We have 5 square roots of 5 minus 7 square roots of 5 would be minus 2 square roots of 5 over 49 minus 5, 44. Now here we've not simplified yet because we notice that this term is 2 times 15 minus, here we have a 2 here, and this is 2 times 22. We can see we have a common factor of 2. Cancel, cancel, cancel. So now our simplified answer is 15 minus the square root of 5, and all that is over 22. Okay, that's the simplified answer. Now that's complete. Okay. Now if we go over to here, simplifying the radicals. All right, in this case, square roots with variables is what we got. So here we have the square root of 25x to the 7th. So one option here is we're talking about a square root. So we're trying to find perfect squares. So one option would be to say, all right, well, I got 25. Well, 25 is a perfect square. And what about x to the 7th? What does x to the 7th mean? It means x times itself 7 times. So that means we have, one way to think about it would be x squared times x squared times x squared times x. So there's x multiplied out 7 times. And why I'm writing it like this is because x squared is a perfect square. So that means I could take the square root of it. So now I'm just going to write out so you can see the steps. 25, square root of 25, square root of x squared, times the square root of x squared, times the square root of x squared, times the square root of x. Well, what do we have here? We have 5. Now we have the square root of x squared, which is x, times the square root of x squared is x, times x. So essentially what I have here is x cubed, and then what's left is the square root of x. Okay? So there's that one simplified. And it's not the only option, but that's one way to do it. Same thing here, simplifying the, right, 4 times the square root of 9 x cubed y to the 5th. Do the same thing. This is going to be equal to 4 times, we think about this, we have 9 times x cubed is, since I'm taking a square root, I want to think of perfect squares. So x cubed is x squared times x. And what about y to the 5th? That's going to be y squared times y squared times y to the 1st. There we have our 5 y's multiplied. There's our 3 x's. And now I could take the square root of 9, which is 3. 3 times 4 is 12. I have the square root of x squared here. What's the square root of x squared? X. I have the square root of y squared, y, times the square root of y squared, which is y. So here we have the square root of y squared, y times y. That means I'm going to have y squared. And then what's left underneath? I took the square root of 9. I took the square root of x squared. I took the square root of y squared. I took the square root of y squared. So what's left underneath is xy. So there's the simplified answer for that one. Okay. So that kind of takes care of between yesterday and today here with this video, the rest of the kind of problems for the assessment. There's also the problems on Delta Math to review. You want to make sure you go through them, look at your answers, watch the video. Let me know if you have any questions on this. Okay. Make sure you review those complex fractions, adding and subtracting fractions with your common denominators and such. Okay.